Hello everyone and welcome to this video. In this video, I want to talk a bit about one bit large language models, why I think that they are so important and why they can completely change the future which we are living in. This video will be very much practically oriented. So even if you do not have too much knowledge about large language models, it's totally fine. The reason I'm making this video is so that it reaches to a large audience. Even if you're a beginner in the ML space, even if you're a beginner in the AI space, I'll make sure to not make this video too complicated so that you can still appreciate this recent development which has happened. The reason I was motivated to make this video is because last week I made this post on LinkedIn where I was so impressed with the Microsoft 1-bit LLM that I wrote that all of these things can be possible in the near future due to the development of 1-bit LLM. In a remote village, a student can use a mobile device with a 1-bit LLM to get personalized tutoring without any internet access. In a low resource clinic, healthcare workers use a mobile app with a 1-bit LLM to diagnose common diseases from symptoms or images offline, even if internet is not present. Farmers can use a 1-bit LLM app to diagnose crop diseases and receive personalized farming advice based on soil type and weather patterns. In a disaster prone area where Wi Fi connections and networks could be completely cut off, a 1-bit LLM powered application can help responders and citizens communicate critical information in multiple languages that too. Imagine getting on an aeroplane and you met with a person who speaks a different language. Let's say the flight is has taken off and there is no internet connection. What if you have a translation application on your phone? It's LLM powered and you can use it real time to conversate with that person. All of this is possible. And the reason I think all of this is possible is because Microsoft recently open sourced bitnet.cpp. So you can search bitnet.cpp and you'll get this repository link. This repository link was made live 2 weeks back, and within 2 weeks, it has 11,000 stars, which is a pretty big deal on GitHub. So, when I made this post, people who knew about LLMs are pretty excited about this. But they were also asking me that, okay, this all looks cool. Can I test it on my local machine? Can I try to download it and see what's going on? Even people who are not aware of large language models, they asked several questions in the comments, such as, how can I directly start implementing this because this seems very useful? Then I was thinking that instead of just making a LinkedIn post, what would really add a lot more value is if I could run this repository on my local machine and get it to work on my laptop. That is when I think this can add value to a much larger set of people, because if you follow this video, you will also be able to run this GitHub repository today on your laptop and get wonderful results, and hopefully you will be convinced like I am that this can completely transform the LLM space as we know it, and it can lead to a huge number of implications. So now let me come to this initial section of this video, which is regarding 1-bit large language models and what's the big deal about them. Imagine you are in a village where there is no internet connection, and you want to interact with an AI tutor. What are your options? The first thing is that, okay, let's go to Chat GPT. But you cannot do this because remember, you don't have an internet connection. So this option is ruled out for you. The second option you might think is, okay, there are so many open source models out there, such as Llama is there, Falcon. So many open source models exists. Why can't I just download one such open source model on my phone or on my laptop, and then I'll use that? I don't need internet connection, right? Once I download the model. The problem in this approach is, look at the sizes of these models: 7 billion, 13 billion, 30 billion, 70 billion for Llama 2. It's impossible for you to download these and run it locally on a CPU. you need GPUs to run these models. So it is very difficult to run large language models offline. That's the problem which we are solving here. And that's where one bit LLMs comes into the picture. The idea behind one bit LLMs is pretty simple. There was a paper published last year where it all started. That is called BitNet. And the idea which this paper introduced is that if you look at transformers originally, the parameters or the weights which are to be optimized are floating point numbers like 1.23, 2.45, 2.86. They are 16-bit values. So this paper proposed that why can't the weights of or why can't all the parameters be just plus 1 or minus 1? That's it. Sounds like a crazy idea, right? But it turns out that it actually works. It works very well in terms of performance. So bitnet, so they called this model which has this one bit transformer architecture. Why one bit? Because it's plus 1 or minus 1. So if you take logarithm of 2 to the base 2, it will be 1. That's why it's 1 bit. So here they called this architecture as the one bit transformer architecture, and they said that this architecture, even if we replace the floating point with this one bit architecture, we get competitive performance with models such as Llama. And not just that, the memory footprint and the energy consumption of one bit models is much lower, is in fact significantly lower than the previously used 16-bit models. That's the main point. So this architecture was called as bitnet. Then came another paper which is called the era of one bit LLMs. This paper was released by Microsoft. They made one change. They said that instead of the weights taking the values plus 1 or minus 1, why can't the weights take three values? So minus 1, 0, and 1. So if you take the logarithm of 3, because there are three values to the base 2, it leads to 1.58. So they call this transformer architecture as bitnet B 1.58. So they released this paper, I think, around 8 months back. And here they showed that again the performance was awesome. You can see in this demonstration that we replaced the floating point values in transformer LLMs with minus 1, 1, and 0. The performance was as comparable to large open source models like Llama. And not just that, the memory footprint was significantly reduced. So if you look at these graphs, if you look at the graph on the left hand side, it's the decoding latency, which means how fast we can do the inference. And we can see that the bitnet and the llama, you can see that the latency for llama is much higher, which means the delay in llama is much higher than bitnet. This shows that the inference speed of bitnet is faster. That's good. Now if you see the model on, or if you see the graph on the right hand side, it shows the memory consumption. Again, the blue line here shows llama. Remember, Llama is an open source model by Facebook with a huge number of parameters. It's not 1 bit, it's 16-bit. So this blue line shows the memory consumption. And as the model size increases from 1.3 billion to 3 billion to 7 billion to 13 billion to 70 billion, the memory consumption just goes on increasing. Whereas if you see the orange line, first of all, the memory consumption for the bitnet architecture is much lower for lower models, and then the difference goes on increasing as the model size increases. This is pretty awesome because the memory consumption for a bitnet B1.58 is 7 times lower than Llama for a 70 billion model. That's why suddenly it opens the door for asking the questions like, oh, this is cool. Does this mean that I can run the bitnet language model on my CPU? And that's what these people claim. Let's look at their claims towards the end of the paper. What they say is that the use of these 1.58 bit LLMs has the potential to greatly improve the performance of language models on edge and mobile devices. These devices are often limited by memory and computational power, and that's why open source models like Llama cannot be used. However, the reduced memory and energy consumption of 1.58-bit LLMs allows them to be deployed on these devices, enabling a wide range of applications that were not previously possible. Which applications? The applications which I showed you over here, all of these applications. and this can greatly enhance the capabilities of edge and mobile devices. Moreover, 1.58-bit LLMs are more friendly to CPU devices, which are the main processors used in edge and mobile devices. This is the part which really caught my attention, because if we can run these open source LLMs on CPUs, that means we can download them. Their memory footprint is anyway lower. So even if now, if imagine the scenario again where you are in a remote village, you can download these 1.58-bit LLMs on your laptop or on your phone, and without internet, you can ask questions to your educational tutor. Imagine the potential it has to revolutionizing education and making it equitable, especially AI education in areas where internet connection is not there. So this is the introduction which I wanted to show to all of you. And now comes the main point. Okay, all of this is pretty cool, but can I implement this on my local machine? Can I download Bitnet on my CPU and get some results? So let's get started with the implementation. They have this GitHub repository here. I'll share the link of this repository. And when they release this repository, there is also a list of instructions to clone this repository and how to build this project and how to run it on your local machine. I encountered a number of issues and setbacks while running this, and my hope is that I'll go through all of those so that you don't make the same mistakes and you can very easily run this code on your own. First thing I want to show you is my configuration of my PC. So I'm using a MacBook Air 2020. So let's see the configuration. And I'll run it on a CPU. So don't worry, I don't have any powerful GPUs. So here's the configuration. The memory or the RAM is just 8 GB for me. It's the lowest version, and my storage is 256 gigabytes. All the modern laptops which came after 2020 have much higher configurations than this. So I am on a configuration which I would say is medium, average configuration. And if it works on my machine, I'm pretty sure it will work on Mac, Windows also. The tutorial which I'm going to be showing you right now is for Mac, but the same exact same things will be applicable to Windows as well. I'm aware that many people in the audience might be having a Windows OS, but it's fine. At every place, I'll tell you the corresponding instructions for Windows as well. So with this background, let's get started with cloning this repository and implementing it on our local laptop. So I'll be sharing this Word document with you in which I've written the 8 steps for installation. If you are using Mac, you will first have to install Homebrew. After you install Homebrew, you can install other packages through it. If you are using Windows, you won't need to use Homebrew. You can just install Visual Studio, and within Visual Studio, you will need to install additional tools which are mentioned here, such as CMake or CLang, etc. So I have a Mac, so what I'll do is that I'll first install Homebrew. To do that, I'll follow these instructions. So the simplest way to do this is just copy this, go to your terminal. So here you can see that I'm going to my terminal here. I'll probably maximize the screen a bit and I'll paste these instructions. I've already run this, so I won't run it again. But once you do this, it will make sure that Homebrew is installed on your Homebrew is installed on your laptop. So I'll just clear this since I've already installed it. So I'm terminating my the terminal right now, and let me open it once more. Right. So once you do these steps, Homebrew will be installed. Then what we have to do is we have to install these two packages or tools, I would call it, CMake and CLang, which is LLVM. So the way to install them is brew install CMake and LLVM. So I'll go to my terminal right now again. I'll go to my terminal and I'll just maximize this a bit, and I'll type here brew install CMake and LLVM, and you can press enter. It will take some time for these to install. Don't worry, I'll share this entire Word file with you. If you are using Windows, then you will have to go to Visual Studio, and while installing Visual Studio, there is an option which you can choose, which automatically installs tools like CMake, and you will also need to install CLang. It shouldn't take much time, but you can start with installing Visual Studio 2022. After that, it's highly recommended to install Conda. So I'll just copy this, and I'll again go to my terminal and click or type brew install cask mini Conda. This will install the Conda environment through which we'll be installing Python. Here you can follow similar instructions for Windows. So basically, three things are needed. You need CMake tool, you need CLang, and you need Python, whose version is greater than 3.9. As long as these three requirements are satisfied, you are okay and ready to move with the next steps. Okay. So I've reached this step right now where I've installed Homebrew, I've installed CMake, CLang, and I've installed Conda. Now I'm ready to do manipulations with this repository. The first thing which we have to do is clone the repository. So as I've mentioned here, you need Git for Windows. If you are using Windows, I recommend Git Bash. You can even do the programming through Visual Studio, or you can use GitHub Desktop. Anything is fine, but you can then do Git clone. So I'll go to VS Code terminal right now, and I'll type this. I'll show you the command. So I'm just going to copy this, and I'm going to type this. So once you do this, a folder will be created on your desktop. Let me just show you that folder. Um, yeah, so here you can see this is the bitnet folder which will be created, and within this there will be another subfolder called bitnet. This is that subfolder you will need to navigate. So the second thing you have to do after cloning the repository is to navigate to the bitnet folder. So that's what I'm going to do. I'm going to do cd bitnet. That will take me to the actual folder where all the code is stored. Right. And then what we have to do is that we have to create and activate a Conda environment. So I'll copy this statement first that will create Python 3.9 environment, and then it will activate this environment in the bitnet CPP. So it will activate the bitnet CPP environment. So I'll just type in this right now. This I'll type in first. And the second statement which I'll type in after this is second statement which I'll type in after this is conda activate bitnet CPP. So here you can see conda activate bitnet CPP. This is what I've typed in right now. And the third statement is pip install requirements.txt. This will make sure that requirements which have not been previously installed will be installed onto your desktop. So pip install requirements.txt. Until now, if you have followed until this step, which means you are until here, step number 6, which means that the project is set up, the requirements have been installed. Now comes the next step. The next step, as has been mentioned in this, is to build the project itself, and that is done in just one line of code. So if you zoom into this statement, what we are doing is that we are going to run this setup dot env or environment file in the repository, and then here there are multiple things which are actually happening. We are downloading this model from Hugging Face, and then we are converting it into the gguf format, and we are building the project. So there are three things which are happening. We are downloading the model from Hugging Face, we are converting the model into gguf, which is a quantized format. Why do we need to convert it into a quantized format? Because that's the protocol for reducing the precision of the weights so that the memory footprint is reduced. I'm not going into the technical details too much here, but there is a huge amount of technical ground to be covered. What is gguf, then what are quantized activations? So many things are there, but I want to keep this video as practical as possible so that it will be useful to all of you. One thing where I made a mistake where I ran this code originally is that if you just copy what is mentioned over here and if you run it on your CPU, your computer will crash if you have the configuration like I have. And that's the mistake I was making. So if you see, if you scroll over it, over up, there are basically three models which bitnet.cpp supports, and the number of parameters go on increasing. I first, if you run this command which they have written in their repository, this model has the largest number of parameters. The Llama 3 8 billion. It has 100. It has 8 billion parameters. You should not run this if you have a configuration like my laptop 8 GB RAM. Instead, we'll run the smallest model which has 700 million parameters. That is bitnet B1 58 large. right? So the code what I have written here is that I've changed this thing a bit. I've changed I've changed this part a bit and replaced their model with this smallest model. That's why you see here there is 1 bit LLM slash bitnet B158 large. That is actually this model over here, which has 700 million parameters. And this model is actually provided by Hugging Face. So you can copy it and paste it over here, and you will see that this model is provided by Hugging Face. It's available here. So with this command, what we are doing is we are downloading this model from Hugging Face, we are converting it into gguf format, and then we are building the project. So I'll copy this command and I'll paste it over here. If this command runs successfully for you, most of the thing has already been implemented and you don't need to worry about uh, too many other details of implementation. You're good to go. And then you will see the inference in the next step. After this command has been implemented, that's it. So which means the project has been built, the LLM is now downloaded and sitting on our local machine. Now comes the last part, which is running inference. This means that here we can give in any statement and get the responses from the large language model. Now, one thing which I would like to mention before I show you some responses is that this model is in developmental stage, which means that it's not yet designed to follow instructions, but it's currently at the stage where it can fill in missing pieces. So it's a generative model and it predicts new tokens. So that's what we'll be testing. We'll be testing the ability of the model to predict new tokens. They are fine tuning this model further and further, and it will get better at following instructions. But right now, even if we produce an output which is barely meaningful, it's a big discovery and it's a big breakthrough, because that means that locally we can run all of these things, right? So now this model is sitting and it's locally sitting on my machine. Now I don't need any internet at all to run this next step. That's the most important part of this video. I'm going to run inference without any internet connection. So in chat GPT, when you want to say that tell me how photosynthesis works, you need an internet connection, right? Now I'm going to run this without any internet connection. So this is the last step, which is running inference. So we are going to run this file run underscore inference.python.py. We are going to use this large language model, the one which we have already downloaded from Hugging Face, and the pre-trained model. And the statement which we are giving is photosynthesis is the process by which plants make their own food. This process is essential because, and we will say that predict 100 new tokens with a temperature value, let's say we give as zero point 0.1. So if the temperature value is zero point 0.1, it controls the variability of the output. Now imagine there is a student in a rural area where internet connection is not there, but they want to learn about photosynthesis. They can interact with this application which is downloaded even on their phone or on their laptop with minimum RAM, like my laptop. So you can copy this, and I'm going to paste it over onto VS Code right now. As I mentioned, I'll change the temperature to zero point 0.1 and let me press enter. So you can see that the new tokens have been generated. And here is the, let me actually zoom in a bit. Yeah, so this is my output. Photosynthesis is the process by which plants make their own food. And this process is essential because plants need to make their own food. That's the output which has been given right now. So as we can see that the output does not make too much sense, but at least new tokens or new words are being predicted. Let me try having generating a lesser number of tokens. So let's say I generate 10 tokens with a variability of zero point 0.7, or let's say 50 tokens with a variability of zero point 0.7. Okay, now we are getting much better responses. Photosynthesis is the process by which plants make their own food. This process is essential because plants use sunlight and water to make their own food. Photosynthesis is the most important step in this process. In addition to this process, plants also use the chemicals in the soil to make their food. Isn't it awesome? Without any internet connection, I am now being able to run a large language model for educational purposes on my local laptop, just on my CPU. And although the quality of the responses can be improved much more, I believe that this research will get to a stage where it's fully ready, like ChatGPT, the quality of the responses. Let's try some more. So let me try to run this. Humans need food, clothing, and Let me see if the model is able to complete this. So the command which I've given is humans need food, clothing, and I've run this model. So here you can see humans need food, clothing, and shelter. That's the completion by this bitnet CPP 1 bit model running locally on my CPU. There are so many things which you can see here, and I can explain to you all of these, like uh, what is the meaning of all these things, such as embedding, then context, the vocabulary, dimension, key, query value, dimensions. We are using positional rotary encoding here, but I'm leaving this out because I want to make this video as practical as possible. The next statement which we are going to run is that once upon a time in a faraway kingdom there was a. So let's say if there is an English student who wants to improve his or her creativity, let's see the story which is generated by this large language model. So I'm going to run this inference now. Once upon a time in a faraway kingdom there was a, and let me click on enter. Here you see now uh, the story which the LLM has come up with. Once upon a time in a faraway kingdom, there was a young man named Artemis. She was the daughter of a great king and the mother of a goddess. When she was young, she was sent to live with her father in a great palace. So the story can, of course, be better, it can be improved, but we are already getting there, right? The reason this work is so crucial, I think, is that I can already see that in 6 months this will get to a stage where uh, people in remote villages in India can use this software on their phone or on their CPU without needing any internet connection. So all the processes which I showed you right now, exactly similar processes can be replicated for Windows as well. If you have any doubts or any questions, you can comment on this video, and I'll be happy to debug it as much as possible. But it's very important for you that instead of just watching this video, you can try to be involved in this research. You can try to be involved in this field which is so rapidly developing. This was released 2 weeks back, right? So it feels great that we have tried to implement something which was just released right now. In fact, if you see the issues over here, from our team, we were one of the first ones to comment on the issues on this repository. And now there are around 60 issues. So it feels good to be at the cutting edge of technology like this. And this, I believe, can be a game changer in the future. The reason I constructed this video is so that along with the theory, you also appreciate the practical implementation of this. So many people are requesting on LinkedIn as well to make a video such as this, which demonstrates the practical applications. I'll probably also make a theory video which explains why do one-bit LLMs really work. It seems like magic. How can replacing these floating point numbers with 1, -1, and 0 actually work? There's a very nice mathematical theory to it. There is also something called quantized activation functions, which we'll get into later. But to just show you a schematic of the architecture, this is how the bitnet architecture actually looks like, based on which this entire technology is evolving. So this brings us to the end of this video. Thanks a lot everyone. I hope you enjoyed watching the theoretical aspects as well as the practical demonstration of what I believe can be a major revolution in large language models. Feel free to comment on this video regarding where you think this technology can be useful, or if you are facing any doubts or difficulties in implementing this code on your own, we'll be happy to guide you through this process. Thanks a lot.